Hi guys, welcome back to Exquisite Tutorials, and we'll be starting off your MTH 102 and your MTH 112 with this video. So basically MTH 102 and 112 is all about calculus. It's all about calculus. Although in your second semester you still do differential calculus and some other aspect of calculus, but this is just the basic of calculus, more like an introduction to calculus. So calculus has two branches. It's a very broad part of mathematics, which is very useful in physics and useful in life generally. Let me just put it that way. That's how calculus is. Let me take you back to your chemistry. In your chemistry, you were told that your organic chemistry is very broad because your carbon can form several compounds that are so numerous. So they decided to separate everything about carbon to be one part of chemistry called the organic chemistry. So that's how calculus is very broad. It does not have ending. This is the beginning, but there is no ending for calculus. It's a lifetime thing, especially if you are an engineering student. You do calculus all your life. It's very useful. So let's kick off. Calculus have two branches basically. The first is your differential calculus and the second is your integral calculus. So you can't know integration without knowing differentiation. So before you start integration, you must know this because this is the first to be published. There were actually two people that started calculus. We have Gottfried and Newton, but one of them was seeing calculus as a physics, while the other one was seeing calculus as pure mathematics. So Gottfried actually saw calculus as mathematics, while Isaac Newton saw calculus as physics. So differentiation is actually the rate of change of a certain variable with respect to another variable. Differentiation has to do with how one variable will change with respect to another variable. Let's assume you have a car and you are driving at a certain speed. Now the rate at which you change your distance with time is what we call differentiation. The rate at which you change your distance, probably you are at a junction and every 5 minutes you go through, let's say 5 meter, or that's very slow. Let's say your car is fast and every 1 minute you go through, let's say 2 kilometers. Let's say you are very fast. Every 1 minute you go through 2 kilometers. So the rate at which you change your distance with time is what we call differentiation. And according to what we just explained, that particular rate is what we call speed in your physics. So you see it in maths and you see it in physics. So that rate at which you change your distance with time is speed. But in maths, we just say it's differentiation. Now, there are two functions, two common variables used in mathematics, which is your x and y. We also use other variables, but the commonest is x and y. The rate at which your y changes with respect to s is what we call differentiation. Now, if we have y equals to ax raised to the power n, I'll be starting off with this, although there's something we call first principle, which is a bit difficult to comprehend, especially when you are starting calculus for the first time. So I won't be going into first principle now. In subsequent video, I will talk about first principle, but you have to just know the short way of differentiating. Now, let's say you have y equals to a certain constant. This a is a constant, and this n is a constant. They are known values. Then x and y are the variables. Now, if you are finding the rate at which y changes with respect to x, this is how it is done. The rate at which your y changes with respect to s is what we call dy over dx. And it is actually bringing this power down to multiply this constant here. So we'll be having a times n, then dot your x. Then this power here that was initially here, you keep it. But what you do is that you subtract 1 from it. You subtract 1 from it. Now, for straight lines, for example, if we have a straight line, it is easier to differentiate because the rate at which your y changes with respect to s is a constant value. But once we have a curve, it is very difficult to differentiate because the rate at which it changes varies from different points. At this point, there's a certain rate at which this curve changes. At this point, there's a certain rate that this curve changes. At this point, so this point is where we now draw a straight line. So we assume that at that particular point, the curve changes as if it's a straight line. So at different points, we have different rates it changes. So this rate of change is what we call the gradient. So for Uniben students, if you check your MTH 123 second semester, you will see it's already on the YouTube channel where we talked about the gradient of a straight line. You will see what gradient is all about. Now, let's come back to this. Now, if you have y equals this, your dy over dx, which means your rate of change with y with respect to x, is this power times this, then times subtracting 1 from it. So let's just solve like 4 or 5 examples, and that will be all for this video. Let's say we have a function y equals to 7x squared, and you are asked to look for your dy over dx, the rate at which y changes with respect to x. Now look at this. We said the power will multiply whatever is here. It's possible that this place is x squared, so whatever is here is actually 1, but here we have 7. So there are different possible values. It could be 1 over 3, it could be 1 over 4, and so on. So your rate of change, dy over dx, remember we said this power, we multiply this constant here. So we have 7 times 2. Then from this power which you have here, you subtract 1 from it, 2 minus 1. So your dy over dx becomes 14x raised to power 1. So that's just the answer. That's just the answer. So let's do another example. Let's say 2. You are asked to find dy over dx when y is equals to 1 over 4 y raised to power 7. Or let me say let me just leave it like this. Now remember we said this power will come down to multiply this constant here, then you subtract 1 from the power. So we are going to have dy over dx equals to this 7 is the power which is coming down to multiply this constant. The constant is this 1 over 4. So we have times 1 over 4. Then, sorry, this is x, not y. Then we have x raised to power 7 minus 1. So your dy over dx becomes 7 times 1 is 7. So we have 7 over 4. Then x raised to power 6 because you have subtracted 1 from the power. So that's the answer for that one. Very straightforward. Now, what if this power is negative? Let's say you have y equals to 1 over x raised to power 3. What if it was like this? Now, don't forget that it's always in this form, meaning that your x must not be a denominator. It must be at the top. So from your rule of indices, anytime you have something like this and you are planning to take it up, what happens? A minus sign will come into place. So this can be written as y equals to x raised to power minus 3. If there was 2 here instead of 1, we would have put the 2 here. If there was 3 here instead of 1, we would have put the 3 here. But that's just 1. So instead of writing this as 1 over x cubed, I can as well write it as x raised to power minus 3. So that it will come up and look like this. Now in this case, if you observe, now the a here is actually 1. 1 times this. Then your n, this power n, is actually minus 3. So we cannot differentiate easily. Our dy over dx becomes 1, which is this a, times the power, which is minus 3. Then you subtract 1 from this power. We have x raised to power minus 3. Then subtract 1. So that will be dy dx. So finally, we are going to have dy over dx as minus 3, because 1 times minus 3 is minus 3. Then x raised to power, we have minus 3 minus 1, which is minus 4. X raised to power minus 4. So this is actually what we call the rate of change of y with respect to x. So you call it dy dx, or you can call it the gradient. So this will be your answer. Or since there's a minus sign here, you can decide to bring it down back again to look like the original question. So your dy over dx becomes minus 3 over x raised to power 4. That's just the answer. Very straightforward and easy. So what if it is of this form? So there are different forms you can see these questions. Now what is it? It was in this form. Let's say we have y equals to cube root of x raised to power 4. Now remember from your indices that whenever you have the mth root of x raised to power n, that it is equivalent to x raised to power n over m. So I can change this and write this to be x raised to power 4 over 3. If there was nothing here, it means it was square root, so it would have been x raised to power 4 over 2. So if here was 7, this place would have been 7. If here was 1 over 4, this place would have been 1 over 4. So the 1 over 4 would have, the 4 would have come down. But here is an odd number. It's possible that it's 1.3. It's possible that it's 1.5. But in indices, this is a standard rule of indices, that whenever you have the mth root of a function raised to power a certain power, it is equivalent, or it can be written as x raised to power this. So now we cannot easily differentiate since it's already in this form. There's a power here and there's something multiplying it. So your dy over dx becomes, what is your a? Your a is actually 1. So we have 1 times, what's the power? 4 over 3. So we have 4 over 3. Then what do you do to the power? Don't forget, you always subtract 1 from the power. So we are left with dy over dx is equals to 4 over 3 x raised to power 4 over 3 minus 1 is the same thing as 4 minus 3 over 3. So this is 1 over 3. So this is your final answer, or you can decide to leave it in this form. You know that x raised to power 1 over 3 is the same thing as the cube root of x. So instead of writing it as 4 over 3 times x raised to power 1 over 3, I can write it as 4 over 3 then x raised to then cube root of x. So I can write it as this. So that's for example 4. Let me give 2 more short examples, very brief examples. Then I'll give you some standard functions that once you differentiate, you get the answer. Then in our next video, we'll talk about your chain rule. So this one is basically something you should just know offhand. You don't need to go through all this process. So if you have y equals to 4x, for example, now the power of x here is actually 1, which means your n is 1, and this a here is 4. So if you are differentiating this, you are going to have 4 times 1. So your dy over dx will be 4 times the power 1, then x raised to power 1 minus 1. So 1 minus 1 is 0. X raised to power 0. Remember from indices, anything raised to power 0 is 1. So long that thing is not 0. 0 raised to power 0 is actually undefined and it's not 1. So this part becomes 1. So we have 4 times 1 times 1. So our dy over dx becomes 4. Now take this and know this. Anytime the power of x is 1, just take this coefficient of x as your differential, as your rate of change. So if we were having y equals to 5x, your answer would have been 5. If we were having y equals to 20x, your answer would have been 20. If we were having y equals to, let's say, 1 over 3x, your answer would have been 1 over 3. So whatever is multiplying x, so long that the power of x is 1, that means we just have only x. Your differential, if you differentiate, you are going to have that coefficient there. So for the last one, if you are differentiating a constant, now let's say you have y equals to 3 and you are asked to find your dy dx. So the problem here is that there's basically no x here. That's where the first problem is. There's no x here. Now how do we introduce x to be in this place? We can manipulate and do some things here. Now Shebe, we said x raised to power 0 is 1. So this 3 can be written as 3 times 1. So this 3 times 1, that 1 that we are multiplying with, can be written as x raised to power 0. So instead of me to write y equals to 3, I can write y equals to 3x raised to power 0. Since I know that x raised to power 0 is 1, so it's basically the same thing. Now I cannot easily differentiate since the variable x is here. So what will be our dy over dx? Our dy over dx becomes 0 times this, remember the power times that, which is 0 times x raised to the power 0 minus 1. 0 minus 1. It does not matter what you have here. 0 times anything will automatically give you 0. So your dy over dx is 0. Now, anytime you differentiate a constant where you can't find any x is a constant, just know that your answer is always 0. If you're asked to differentiate 5, your answer is 0. If you're asked to differentiate 10, your answer is 0. If you're asked to differentiate 50, your answer is 0. So these are the 6 basic examples I can just use to show you differentiation. Now, what if you have two functions adding up together? Let's say you have y equals 2x plus 5x squared. Now, anytime you see something like this, it's the same thing as differentiating this, then adding it with the differentiation of this. So let's just find dy over dx. Our dy over dx, if I differentiate this, I'm going to have 2 times 1, 2, then x raised to the power 0, plus, if I differentiate this, I'm going to have 5 times 2, which is 10, then 2 minus 1 is 1, so we have x raised to the power 1. So just know this, that when two functions add up together and you are differentiating the final result, it's equivalent to differentiating one first, then adding up with the other one. So if there was a minus sign here, there would have been a minus sign here. So that's for the simple differentiation. So let me just draft out a table that you use. You have to cram this table because it will be very, very useful. You have to cram this table. It will be very, very useful. Then when we talk about first principle, you'll be seeing the reason why we have this, how it was gotten actually. So let's say we have y and we are looking for dy over dx. Now, if you have sin x, if you have y equals sin x, when you differentiate sin x, you are going to have cos x. It's a standard, you have to cram it. If you have sin x and you differentiate sin x, you are going to have cos x. If you have cos x and you differentiate cos x, you are going to have minus sin x. If you have tan x and you differentiate tan x, you are going to have sec square x. If you have cot x and you differentiate cot x, you are going to have minus cosec square x. If you have sec x and you differentiate sec x, you are going to have sec x tan x. If you have y equals to cosec x and you differentiate this, you are going to have minus cosec x cot x. Minus cosec x cot x. That's not all. Then if you have y equals to exponential x, you are going to have, if you differentiate it, you are still going to have exponential x. If you differentiate exponential x, you will get exponential x back. Then if you have ln x, the logarithm of x, and you differentiate it, you are going to have 1 over x. It's a standard. You are going to have 1 over x. If you differentiate ln x, you get 1 over x. Then lastly, if you have a raised to the power x. Now look at this part, it's very confusing. If you observe all the questions we have been solving, x is down, not a power. Now what if x was a power? If x was a power, when you differentiate, you are going to have ln a, this thing that is raising x, then times this same function, a raised to the power x. So that's the basic ones you need to know. From these several functions, you can get them. In subsequent videos, we will talk about hyperbolic functions and differentiation of inverse trigonometric functions and so on. So I urge you, just cram this table or make sure it's already in your head that whenever you differentiate sin x, you are going to get cos x. Whenever you differentiate cos x, you are going to get minus sin x. Whenever you differentiate tan x, you get sec square x. So that's basically what I want you to cram. So in our next video, we'll talk about other rules of differentiation. So that will be all for this video. Please do not forget, like and subscribe to Exquisite Tutorials. If you have any issues in mathematics in your MTH 102 or your algebra, trigonometry, just state it in the comment section and we'll do a video for it. Well, your comment is very, very important, because if you give us your comments, we'll give you what you actually want. So tell us how you feel about this video. If you didn't get what we did here, you can still state it in the comment section and we'll do a video for you so that you get it better. So thanks for watching. Please do not forget to share this video. Thanks once more.